Alright, hello. This is going to be with 14.2, adding and subtracting polynomials. So with adding polynomials, one of the first two things we want to do is write them vertically, or actually we want to make sure that when we rewrite them vertically that all of our like terms are aligned. So in this case, looking at my negative 5x squared and my 8x squared, I'm going to write those in order above each other. Alright, that is taken care of. Then I'm going to look at just my x's, at least in this case. So I've got plus 6x and then plus 9x. And finally, the negative 14 and negative 11. And we are adding these. So we want to write them vertically with like terms in order. You can do this side to side, but it tends to work a little easier when it is vertical. From there, we're just going to go ahead and add like terms. So the negative 5x squared plus 8x squared, really what I can think about is that x squared is going to continue to be there, it's just those numbers in front. So negative 5 plus 8 is going to get me 3x squared. Going next door, 6x plus 9x, again both of those have an x. 6 plus 9 is 15, that is positive, so I'm going to add a plus sign in front of it. Then finally, negative 14 plus negative 11, this is going to continue to get negative, so I'm going to have negative 25. And that answer there at the very bottom is our addition for polynomials. When it comes to subtracting polynomials, the first thing we're actually going to want to do is the distributive property. So this minus 1 or minus here is the same as distributing or multiplying negative 1. So what that is going to do is that is going to change all of these terms to the opposite symbol, or it's basically saying take what you have here and make them opposite. So instead of positive 8x, I'm going to have negative 8x squared. Instead of positive 6y, we'll have negative 6y. Instead of negative 1, positive 1. Instead of positive 4, negative 4x. This is where now we can go ahead and line them up with our other problem. We tend to do it with the highest exponent first. So I'm actually going to then start there. So looking at our left problem, I got negative 25x squared versus that negative 8x squared. So we're going to line those up. It does matter which one is first. Actually, no, it doesn't now that we've distributed. All right, those ones are taken care of. Next, I'm going to go towards, going to continue with my x's. So there's a 5x and then a negative 4x. So plus a 5x minus 4x here. That is taken care of. Now looks like I'm going to go with my y's. So negative 5y and negative 6y. And finally, we're going to end off with those regular numbers, so negative 14 and positive 1. Now, because we went about doing this idea beforehand of multiplying by a negative, this now we can treat this as a giant addition problem. But giving it that opposite is the other way of saying subtracting it. So we don't actually have to go through and think about it twice. We can now go back and say this is an addition problem because I already switched them with the negatives. So negative 25 plus negative 8x squared. I'm going to have that x squared. That should be 33x squared. 5x plus negative 4x. I'm going to get a single x, so plus x. Negative 5 plus negative 6y is going to continue to be negative with a negative 11y. And finally, negative 14 plus 1 is going to get me at negative 13. And there would be our final answer. So with each of these, make sure that they are lined up in terms of all of the like terms are lined up when you go through them, then add it as if it was a normal problem. The nice thing with addition, when you get to this idea of positive minus, you can think of, hey, 5 minus 4 to get to a single positive 1. There's a couple different ways to think about adding and subtracting negative numbers. When you are first subtracting polynomials, you're going to distribute that -1, aka you're going to flip the sign on everything that was in those parentheses, and then you can treat it like another addition problem. All right.